Yeah, sure. So here we have a reaction of ozone. It's going to react with nitric oxide, or NO. So they give us a reaction. Anytime you're given a reaction, you don't even have to read the question right away. The first thing you want to make sure that you do is to balance the reaction. So is it balanced? Yeah, it's already balanced, so good. 4 oxygens on both sides, 1 nitrogen on both sides. That's fine. All right, so here it says I've got 0.740 grams of ozone. And I'm going to react that with 0.670 grams of NO. How many grams of NO2 will be produced? So the question isn't really quite complete. It should say, what's the maximum theoretical amount of NO2 that will be produced? And just because we put a certain amount of reactants in doesn't mean we know necessarily how much product will be produced, because variables like time and heat and the possibility of impurities interfering with the reaction. There's also the possibility the reaction might not be a complete reaction. Some reactions don't produce 100% products. Once the products start to form, sometimes they then collide back together and reform the reactants. And so in those types of reactions, you might never be able to ever get to 100% yield or be able to consume all the reactants. So the way this question is set up, they want us to assume that all the reactants that can react or that are available to react have the opportunity to react. Right? So let's really, to make the question better, let's assume they're asking for theoretical amount of NO2 that could be produced. Right? Really, that's a theoretical yield, what they're asking for. So if I want to know how many grams of one substance in a balanced reaction can be produced, starting from a certain amount of a different substance, I need to convert to moles first. The relationship between those substances is 1-to-1. It's not a 1-to-1 gram relationship, it's a 1-to-1 mole relationship. So the first thing I need to do is to convert this 0.740 grams of ozone into moles of ozone. So oxygen times 3 gives me 47.997 grams of ozone per mole of ozone. This reaction, since everything happens to be a 1-to-1 ratio, right, 1 mole of ozone will produce 1 mole of NO2. And then I want to convert that into grams. So I would get the mass of the nitrogen, 14.007, plus 2 oxygens, and that's 46.005. So I would multiply that all together then. That tells me I should be able to make up to 0.709 grams of NO2. Is that reasonable? Any problems with that? Is there any reason why I might not be able to make this amount? Right, I don't know what's limiting yet. Right, so in order to make 1 NO2, I need 1 O3 and 1 NO. If I don't have any NO, I can't make any NO2. Right, so this is what I've calculated just based on the amount of ozone I've got enough ozone to make 0.709 grams of NO2, but maybe I can't make that much if I don't have enough of the other reactant. So I have to do the same calculation based on asking how much NO2 could I make with this amount of NO. If I don't have enough NO, I can't make as much NO2 as I expected. So I have to do the same calculation. So here I would set it up the same exact way. 1 nitrogen, 14.007, plus an oxygen. That gives me 30.006. That was in grams. Again, looking at the balanced reaction, it happens to be 1-to-1 ratio again. And then the last step is the same because I want to convert from moles of NO2 to grams of NO2. So following the math through on this one, I find that this one, I have enough of this reactant to make up to 1.03 grams of NO2. So what really is the maximum amount of NO2 I could make? Right, it's a smaller one. I've got enough of the NO reactant to make 1.03 grams, but I only have enough of the ozone reactant to make 0.709 grams. That means when I make 0.709 grams, I run out of ozone, so I can't make any more product than 0.709 grams. So this is the theoretical yield. That is the maximum possible amount of NO2 I could make. In reality, I probably won't make that much, because as we said before, over time, once I start to run out of the reactants and the amounts of them go down, the likelihood of them continuing to collide in an effective way goes down, and so the reaction slows down. But theoretically, I could make up to that amount based on the limiting amount of ozone that I have available. So which compound is limiting? Ozone. Because it's the one that I run out of first. It's the one that limits how much product I can make. I have excess of the other one. I have enough of the other one to make up to 1.03 grams of NO2, so that means I have excess of it. So then it says calculate the number of moles of excess reactant remaining at the end of the reaction. So if we assume that this reaction actually does complete itself and produce the maximum amount of NO2 we could make, how much of this excess would be left? In moles. Well, the amount of excess remaining is going to be equal to the starting amount minus the amount reacting. Right? Got a certain amount of it, some of it reacts. Subtract that from the initial amount, and whatever is left over is the amount remaining. So I need to calculate kind of two things here and subtract them to figure out how much is remaining after the reaction. So I need to know the starting amount and I need to know the amount reacting. The starting amount I can get. I've already got that set up. Based on the ozone being, based on the amount of NO that I'm starting with, that's my excess reagent. If I were to stop this first conversion here, that would tell me how many moles, because I have not canceled this yet. Right? That just tells me how many moles of the starting substance I had in the beginning. And that number is 0.02232 moles. I've got 3 sig figs there. So that's the starting number of moles of NO. So I want to subtract from that how much of NO is actually going to react. So I need to do a conversion to figure that number out. So that question is, how many moles of NO are actually going to react? That will be based on either starting with how much of the ozone is reacting or how much of the product is producing. I can do that conversion from either one. Get the same number either way. So maybe I'll do it based on the amount of product produced. So if I assume that the maximum amount of product produced is actually formed, I can convert that amount into moles of NO. That should show me how many moles of NO would have had to have been consumed or reacted to produce that amount of NO2. So I would take the molar mass of NO2, the 46.005 grams of NO2 per mole of NO2 that we calculated. Then I would employ the 1-to-1 ratio that happens to be the case in this case as the way the reaction is balanced, to convert that to moles of NO. So I'd take the 0.709 divided by 46.005, and that gives me 0.01541. Again, I do only have 3 sig figs, but that's the number of moles of NO consumed, because it came from the amount of product produced. And they're produced and consumed in a 1-to-1 mole ratio, and that's what I'm taking advantage of in my calculation. So if this is the starting amount, I subtract from that the amount reacted if I want to figure out how much is left over. .02232 minus that number gives me 0.0069 left over. Here I'm limited to 2 sig figs. Why is that? Because I carried through my calculations when I multiply and divide, my answer is limited by the number with the fewest, which was 3. So I had to limit this 0.02232 to 3 sig figs. If the zeros that come to the left of the non-zero digits are never counted as sig figs. So this had 3, and this had 3. When I add and subtract, the rule is not just the same as multiplying and dividing, where I just go with the one with the fewest. I have to look at the columns. So I've got certainty in this column, in this column, in this column, and in this column. I don't have certainty in this column out here where I don't have a sig fig, so I can't include a significant digit there. And since these turned out to be zeros, those are not significant. I only got 2 columns that actually have non-zero digits in them that are actually significant digits. Questions about that? Yeah, they gave me the grams in the beginning with 3 sig figs. Right, because the zeros that come after the non-zero digits here are significant because there's a decimal shown. You can't see the decimal in these numbers? You got 3 sig figs there. The fact that these have 3 sig figs is not why I only have 2 sig figs in this. The fact that these have 3 sig figs is the reason why these numbers only have 3 sig figs. The reason my answer only has 2 in the end is because once I start adding and subtracting, doesn't matter how many sig figs the numbers have. What matters is when I line up the decimals and actually subtract the columns, that in my answer, I only report significant digits in columns that came from adding and subtracting significant digits for known numbers. I can't take an insignificant digit that's completely unknown and subtract or add something to it and have any idea what the answer is, so I can't have a significant number in that column. So I just happen to have only 2 columns with actually no numbers in them, so that's why it has 2 sig figs in them.